So now we're gonna do procedure 1 for part 1 of charging an object. So for this part, we have a rubber balloon, and what we're gonna do is we're gonna rub it on our hair, and then we're gonna place it either in the wall or on us to see what happens. So rubbing the okay. Ow. This is what happens. So now explaining what happens with the charges in the balloon and our hair is that each of the atoms in the balloon is equally charged, meaning that we have the same amount of protons and electrons. But when we rub it with our hair, we are creating a layer of positive and negative charges, because the charge is polarized, meaning that when we're rubbing it, all the negative charges, so all the electrons, are going to want to come closer to our hair, which is positively charged. And then once we move that balloon and put it into the wall, it's going to stick in there, because all the negative electrons want to attract the positive charges, since different opposite charges attract to each other, and is going to want to stick in there, and that's what happens. And here we go with procedure number 2. We're going to charge the PVC rod with the fur. So we're just going to rub it really quick. We're going to try to charge it as much as we can. And we can already hear some like cracking noise. I don't know if you guys can hear it, but we can already hear it. So then after this, what we're going to do is like the rod, we're gonna get it close to this metal can, and then we can see that it's moving. It's already attracting it. Explaining why the phenomenon happens, it's because when we charge the PVC rod with the fur, this is going to be negatively charged, and once we get it close to the can, what we're going to do is we're going to be polarizing the atoms of the metal can. In this case, it's an aluminum can, and what we are doing in this case is by getting it closer, all the electrons are going to move away, because this is going to be negatively charged, and this is going to attract all the positive charges in the can. If we were doing this with a glass rod, that if we were to rub it with silk, it is going to become positively charged, which what will happen with this is once we get it closer to the can, it's still going to attract, because the can has a neutral charge. But the only thing we're doing is polarizing the charges and creating a layer of positive or negative charges. It depends on whatever rod we are getting close to the can. So either rod should still attract the can, because what we're doing is polarizing it. So now what we're gonna do is we're gonna charge our rod again, but in this case, we're gonna get it close to our electroscope, which is our setup here. So we're gonna go ahead and charge the rod. And then what we're going to do is we're going to get it close to our electroscope. So, this a bit closer. So, there, we're going to get it close. And we can see the leaves deflecting in this case when we get our rod closer to our electroscope. And the reason why the leaves deflect is because they're both going to have the same charge, so that way they're going to repel each other, and we see how they repel each other by deflecting. So now we're going to repeat the same procedure one more time. We're going to grab our rod and then charge it. Once we can hear that cracking noise, it should be fine. And I'll move this a little bit. So we can see that in there, and we can see the leaves deflecting one more time. But this time we're gonna touch it, and now we can see that the leaves go back to normal. So by pulling the rod out, we now see the leaves are deflecting. So what happened when we negatively charge the rod and get it close to our electroscope, now our electroscope became polarized, and once we touched it, we are actually acquiring all the extra negative electrons that our electroscope had, since the negative rod was attracting the positive charges. And once we pull out the rod, our electroscope is going to have more positive charges, and the leaves are going to deflect again. But when we bring it back into our electroscope, the leaves are going to go back to normal, since it's going to be stabilized again once we bring our rod back. I'm not sure if I showed that, so we're just going to do it one more time. So here we can see the leaves deflecting. We touched it and it becomes normal again. And now that we bring our electroscope out, the leaves are deflecting. Bring it in, the leaves go back to normal. Out, deflecting, in, they come back again. Cool. So now doing our experiment one more time, because we are gonna purposely positively polarize our electroscope to determine the charges of different things. We're just gonna go ahead and see how the leaves are deflecting. Now we're gonna touch it and it's gonna go back to normal. And now we're gonna pull the rod out and we can see how it is, the leaves are deflected. And now we're gonna grab, I have a little magnet here, and by getting it closer to my electroscope, we can see how it wants to come closer a little bit. You can see that little movement, which means that this magnet is going to be negatively charged, since our electroscope, we already know it's positively charged, since that's what we did. But in case we grab a glass rod for this experiment, what we would see is that the leaves are going to deflect even more, because we're going to get even more of a positive charge. So now we're going to discharge our electroscope by touching the case and also the terminal. And yes, it does work, because we are the ones acquiring the extra either negative or positive charge that our electroscope has. So now what we're gonna do is we're gonna rub the fur with our styrofoam for like some time, about like 10-20 seconds, trying to get some charge. We're gonna grab our electrophorus. We're gonna put it on top of our already charged styrofoam. Now we're gonna touch a grounded metal surface with one hand, and then with one finger we're gonna be touching the aluminum part of our electrophorus. So, and we can actually hear a spark once we do that. Then touching that, and now what we're gonna do is like lift it about 1 or 2 inches. So now we're gonna repeat the process. You guys already know what to do. We're gonna grab our electrophorus, put it on top, and now we are gonna again touch ground and then touch this, and again we could hear a spark, but this time we're gonna lift it a little bit more than last time. So the second time that we lift our electrophorus, we actually couldn't feel as much force, or sometimes even not a force at all, because the greater the distance, the weaker the force. Okay, so now what we're gonna do is I have a piece of styrofoam that we're gonna tear out. I have little pieces of styrofoam. Repeat the other procedure. Grab our electrophorus. We're gonna put it on top of it, and we're gonna repeat this procedure about 2 times. We're gonna put it back here, and now we are gonna touch ground, and we are also gonna touch our aluminum in the electrophorus. And again, we're gonna lift it, and we can still see that this little pieces are still coming to the aluminum. We're gonna repeat this one more time, and touching ground and touching the aluminum and lifting it, and you can see that again it attracts the little pieces. And the reason why the electrophorus works every time is because the charge in here is never really gonna change. So every time we take our electrophorus and put it on top of our negatively charged styrofoam, it's gonna be the same process, where again the styrofoam is gonna want to attract all the positive charge, and when we touch the top of the aluminum foil and touch some ground surface, we're gonna do the process all over again of giving the electrons a path to ground, and this is again gonna be positively charged, and it will work every time as many times as we do it.